Okie doke. So, hormonal regulation of nutrients. So, soon after a meal, the blood levels of nutrients like glucose, amino acids, and fatty acids start to increase. So, when things start to go into your stomach, we're really not absorbing there. We don't really start absorbing until we get to the small intestine, the duodenum of the small intestine. But as we start absorbing those nutrients there, it actually starts going into our bloodstream. Parasympathetic stimulation and increasing blood glucose levels can increase our insulin secretion. Remember, our blood glucose levels come up and get kind of high. We actually have the pancreas starting to secrete insulin to try and get that blood glucose level down. So nutrients start to move into the cells. Remember what I said, if it's not in the blood, if it's in the cells, technically it's not in the blood anymore. Within 1 to 2 hours after a meal, though, those nutrient levels start to decline. So don't forget that we've got kind of that, yeah, we're doing great, and then we kind of hit our mid-morning low, and then we kind of get another boost, right? We kind of get our second wind. Well, decreasing blood glucose levels and increasing sympathetic stimulation will cause insulin secretion to decrease. Why? Because those levels have gotten too low. I don't want to keep secreting insulin when my blood glucose is already kind of down. Decreasing blood glucose levels and increasing sympathetic stimulation will start to increase glucagon secretion. Remember, glucagon is coming from those alpha cells. Decreased blood nutrient levels can cause an increased growth hormone secretion. Remember that with growth hormone, we also had that increase in glucose breakdown and that increase in fatty acid release and all of that. Decreased blood glucose, really? Okay, decreased blood levels also cause an increase in cortisol secretion. So what does that all mean? Well, the glucose uptake from the cells in the body starts to go down. Remember when we secreted insulin, all of a sudden all these cells in our body became sponges and started taking that glucose out of our bloodstream? Well, that's basically going to switch off. I want to stop them from doing that to keep that glucose in the blood. Instead, they start to switch to fat and protein metabolism. The liver will start breaking down the glycogen into glucose. So it'll start releasing that glucose. It'll start releasing ketones and triglycerides because these are alternate fuel sources. And my adipose tissue will also start to release fatty acids into circulation. Again, remember that at this point, I've reached that mid-morning low after I've eaten, a couple hours after I've eaten. So I kind of need to have an alternative to having, to eat, I don't know, a candy bar or something. Now, let's talk short-term versus prolonged exercise and the differences that happen in the body when we do one versus the other. So short-term exercise, you've got sympathetic stimulation. It starts to increase epi secretion from the adrenal medulla and glucagon secretion from the pancreas. It also inhibits insulin secretion from the pancreas. Why? Because I want glucose in the blood. If I'm going to need it to make fuel, I need to leave it there. Epinephrine also increases the rate at which glycogen in the muscle cells is broken down into glucose. Remember, glycogen is going to be our complex sugar, our human version of starch. So the muscle cell starts breaking that down into glucose. The glucose is used as an energy source in the muscle cells. The muscle cells take up less glucose from the blood and increase their rate of fatty acid metabolism. Okay? Now, Epi and Glucagon increase glycogen breakdown into glucose molecules also in the liver. The glucose molecules are released into the circulatory system. Epi and sympathetic stimulation also increase the breakdown of fat and release of fatty acids from adipose tissue. Blood glucose levels are maintained for our normal nervous system function. Notice how many times I talked about sugar there. Yeah, I talked about fatty acids and fat a couple times, but for the most part, I talked about breaking down glycogen into glucose. I talked about the liver releasing glucose. I talked about sugar quite a bit, right? In prolonged exercise, walking for 45 minutes, I'll go with that. Adrenocorticotropic hormone and growth hormone released from the anterior pituitary. Adrenocorticotropic hormone stimulates an increase in cortisol secretion from the adrenal cortex. Cortisol increases protein breakdown in the muscle and in the liver to amino acids, and that increases glucose synthesis from the amino acids and from some components of fat, such as glycerol. Cortisol increases the breakdown of fats and the use of fatty acids in muscle cells as an energy source. This is kind of the big thing. Prolonged exercise, instead of counting on sugar, now we're starting to count on fats instead. Growth hormone will actually start to slow the breakdown of proteins. Last thing I want to do is break down my muscle if I'm trying to build muscle, right? That actually helps to conserve those proteins. And what that means is I'm going to increase the dependence on fats as an energy source. This is the reason that doctors tell you you need to exercise for like 30 minutes, 45 minutes. Glucose levels are maintained for normal nervous system function, and there's an increased dependence on fats and proteins for energy sources. So the way that your body works normally, it goes after sugar first. Then it'll go after fats. Then it goes after proteins. Proteins are kind of last resort material. So if you can get your body into this prolonged exercise, gear or mode, then your body actually burns fat instead of just the sugars that you've consumed. So the hormones of the reproductive system. So we know that we've got the male reproductive system that has the testes and the female reproductive system that has the ovaries. The male testes create or make testosterone. It makes inhibin. Testosterone in the male body actually does target most cells. It aids in spermatogenesis. Genesis means the creation, right? So making sperm. It also is involved in the development of that genitalia, going from a kid to being a mature adult that can make viable sperm. Testosterone has to be part of those surges of hormones. The maintenance of functional reproductive organs. Again, if you've got a grown man and he's not making enough testosterone, he will not create viable sperm. And just to reiterate, viable sperm means that it will actually fertilize an egg. The secondary sex characteristics, the deepening of the voice, the big barrel chest, the furriness that comes along with puberty, the hair on the face, all of those things are secondary sex characteristics. And then sexual behavior. Oftentimes, if you have a male that doesn't have a sex drive, if you check their testosterone level, it'll actually be fairly low. Now, inhibin actually affects the anterior pituitary. Specifically, it inhibits the follicle-stimulating hormone from being released. So follicle-stimulating hormone is going to either cause the release of the oocytes in females or the sperm in males, or the creation of them. So follicle stimulating hormone being inhibited means you're not making any more sperm, which in reality, there are times when you've already got some, so you don't need any more. Okay, so female, we make estrogen, progesterone, inhibin, and relaxin. Estrogen targets most tissues. It's involved in uterine and mammary gland development and function. So being able to hold a baby, go through our menstrual cycle, our mammary glands actually being able to become active and feed a baby, the maturation of the genitalia, the secondary sex characteristics, which we've already talked about, sexual behavior, and the menstrual cycle. Now, Progesterone is actually fairly similar. There's really only one difference between these two, and that's the sexual behavior. Estrogen affects sexual behavior, progesterone doesn't, but it does affect uterine and mammary gland development and function, maturation of the genitalia, secondary sex characteristics, and the menstrual cycle. In fact, estrogen and progesterone are often the components that you will find in the pill, birth control pills, that basically trick your body into thinking that you're pregnant so that you don't release another egg, and that's how it works. Inhibin actually, again, targets the anterior pituitary, and it inhibits FSH. So in females, this is actually kind of important, because if by chance you have gotten pregnant and you do have an oocyte that is implanted in the uterus, the last thing you want is another one to get released, because if a second one gets released, it can actually attach to the one that's already attached. It can knock off the one that's already attached. It can damage the one that's already attached. So once you have gotten pregnant, you don't want anything else to happen. You want to carry that baby to term. Relaxin targets connective tissues, specifically normally in the pelvic area. So it increases the flexibility of the connective tissue in the pelvic area, especially in the symphysis pubis, where your pubic bones meet. This is one of the reasons why, as ladies are pregnant, it's kind of like their hips widen. If you think of the hips as putting your thumbs together with your fingers up, like you're going to make a butterfly, okay? As the relaxin happens and the baby starts to settle, that baby's weight and the relaxin to the connective tissue actually opens up those hips. So the hips, instead of being up high like a butterfly wing, actually start to create more of a bowl. And that's very intentional, because the more relaxed that tissue is, the easier it will be to actually give birth, to push the baby out of the hole that exists between the two pelvic bones. Okay, so in the female, the placenta actually releases an LH, a luteinizing hormone-like substance. This actually helps to maintain the pregnancy. With the female placenta and the ovaries, through the term of a pregnancy, there is an increase in the amount of estrogen and progesterone being produced. This is actually required to maintain the lining of your uterus so that you can maintain your pregnancy. If those levels drop, basically you're going to start your menstrual cycle, which means it all sloughs off, which means the baby that's there is actually going to be damaged or probably expelled. So having both the placenta and the ovary maintain a certain level of progesterone and estrogen during pregnancy is essential to maintain that pregnancy and keep that baby incubating, I guess, long enough so that it can come to term. So hormones of the pineal body. So the pineal body is actually back here, okay? We don't know. What we do know is in animals, the pineal body has a very specific function in something called the light-dark cycle. The light-dark cycle basically means that for nocturnal animals, if you walk into a room and you turn on the lights, they go to sleep. In fact, working with animals at a lab, if you know that you've got nocturnal animals, the times when you're working with them, you make sure that the lights in that lab are on so that they're more docile while you're working with them. Humans don't really do that, which is where kind of the rub comes in. Because to be honest, if we as diurnal, being awake during the day and going to sleep at night creatures, were that easy to control, we would hate going to movie theaters because the minute the lights went down, yeah, we would want our money back, right? Plus, how many of you know anyone who works at night? So that doesn't really hold water for humans, even though people still bring it up. What we do know, what we have actually found evidence of, children who get cancer on their pineal gland have one of two things happening. Either they never go through puberty at all, or they go through puberty really early. We're talking 6, 7, 8 years old, and they're going through puberty. So there is thought that the pineal body has something to do with the onset of puberty. But other than that, yeah, still kind of up in the air. We do know as well that melatonin gets secreted from there. But again, that whole light dark cycle and how it works in animals versus us,